Hello everyone. So in this tutorial, we'll now see how to set up a case with simulation author mode. So what exactly simulation author mode is? So sometimes user they are not sure about which classes or which relation is to be used while setting up the attribute. So user they are sure about the geometrical location where they want attribute is to be transferred, but they are not sure about the relevant classes or relevant relation that is to be used while setting up that attribute. So in such cases, a user can just select the geometrical entities and they can create the attribute, and CAENexus will assist them in finalizing the relevant classes or relevant relation on which they can specify that attribute. So this assistance is done through a functionality called as simulation author mode. So let's see how exactly it works. You can see on my screen, this is the abstract model file which I have opened in CAENexus. Again, I've taken this file from the scratch folder, and this file is missing some attributes. So we'll be seeing how to create those missing attributes through simulation author mode. So the first step is to create a simulation model. So where we actually link our abstract model file with the CAD geometry. So to do that, one need to click on this icon, that is simulation model. Then it will ask for the CAD geometry which is to be linked with this abstract model file. So I'll just select the coupling FEA assembly, and this will now create the simulation model. That is your abstract model file and your CAD model will get linked, and this is your real model. So the first step is to create this simulation model for using the simulation author mode. To enter into simulation author mode, one need to click on this icon, that is simulation author mode. And once you click on it, you are in the simulation author mode now. Let's now create the missing attributes. So first is solid element set attribute. Now I want solid element set attribute is to be transferred on three regions. That is this region belonging to one hub, region belonging to this pin structure, and the region belonging to this another hub. So for that, I'll just select these three regions in the graphical user interface. For that, I'll first click on this icon, that is pick region. Then I'll select these three regions because I want to transfer the attribute on these three regions, and then I'll create the attribute. So for that, I'll go in create, problem definition, element, solid, and specifier. Now this will show me some abstract entities. So these entities are belonging to these three regions. So you can see there are 10 entities and they are arranged in such a way that the topmost entities are more relevant to the geometrical selection, whereas the bottom entities those are less relevant with the geometrical selection. So what I mean by most relevant and the less relevant, so most relevant means these entities will exactly capture my geometrical selection, whereas the less relevant entities they may be partially capturing my geometrical selection, or sometimes they may be capturing more geometrical entities along with these geometrical entities. Now we need to choose one of the abstract entity from this 10 entity. So you can click on every entity and you can verify whether it's showing the geometrical entities which you are looking for. So for example, I can click on this entity and yes, it is showing the geometrical entities which I actually want. Maybe I can click on another entity. So you can see now it is showing region for that bottom plate also, but that is not my area of interest, so I'll not go with this entity. Similarly, I can click on any other entity and it will highlight the respective geometrical entities. So one can confirm which entity they actually want by just clicking on those entities, and the respective geometries will get highlighted in the graphical user interface. So for me, I'll go with this entity because it is covering the geometrical location or the geometrical entities which I actually wanted. One more thing is the naming of this entity is in line with my tagging nomenclature, because I know that I want to use steel1430 class for setting up the element set attribute. I know that the size class I have added in my CAD model because I want to use mesh size related attribute. I have added contact class in my CAD geometry because I want to create contact related attribute with that class. So based on your tagging nomenclature and based on the geometrical entities, one can confirm which abstract entity you should go with. So in this case, I'll just go with this. So for that, I'll just click on this checkbox and I'll click on next. This will now open the attribute editor. So you can see here in the model association that prune 3D of steel 1430 has come. So it means CAENexus has assisted me in finalizing the abstract entity for setting up this solid element set attribute. Now I can set up or I can select different parameters in this attribute, maybe P solid. So I can just select the material here. It is 1430. I'll just name this attribute as steel 1 and I'll just click on apply and close. So you can see here the attribute is now created. So this way, by selecting the geometrical entities, we can create the attribute, and CAENexus will assist us in finalizing the relevant classes or relevant relation. Similarly, we'll see some more attributes. Now, I want to create a load attribute, and I know the location where I want to apply a load. So let's see how to create that attribute. So I'll just first select the geometrical entity on which I want to apply the load. For that, I'll first hide this face. So by Control H, you can hide it. And I want to select, or I'll select these two faces because I want to apply a load at these two locations. After that, again, same procedure. I'll go in create, problem definition, load, and point force. Now this will assist me some abstract entities as well as some abstract relations. So in this case, I'll go with the relation. Again, one can confirm the abstract entities or the relations by click on that and the respective thing will get highlighted in the graphical user interface. So in this case, I'll go with the R load solid relation because it gives the geometrical entities which I am looking for applying the load. One more thing, this relation is not present here in this class relation window. So for that, I'll have to first add it, and this plus sign is given to add that relation in the abstract model file. So once I click on this plus sign, you can see the relation has been added here in this class relation window. Now I'll just select this checkbox and I'll go with the next. So this will open my attribute editor and I can fill the details as per the requirement. So I want this load is to be considered in the second sub case. The magnitude is minus 5000 and should get applied in the y direction. I'll just click on apply and close. So you can see here this attribute is now created. So by selecting geometrical entities, Again, CAENexus assisted me for selecting the relevant relation on which I should give that attribute. Let's see a couple of more attributes as well. Let's see how to create a contact pair attribute now. I know that I want contact of this pin structure with these two hubs. So I know the geometrical location where I want contact is to be specified. So I'll first select those geometrical entities. So I'll first hide this face. Now you know that contact pair attribute is specified on the face use. So I'll just select here the face use icon and then select the relevant face use on the screen. Then I'll go in create problem definition and then contact and contact pair. So this will assist me, or the CAENexus will assist me some abstract entities and abstract relations which are corresponding to my geometrical selection. So in this case, I can click on this relation and I can verify whether it's highlighting the correct geometrical locations or not. So I know that I want to define contact at both the ends. So it is giving me the correct geometrical entities. So I'll go with this relation. Again, this relation is not present here in the class relation window. So I'll click on this plus sign. It will get added here. And then I'll click on this checkbox and I'll click on next. So this will open my contact pair attribute. I can fill the necessary details like contact type, maybe slide, orientation, open gap here, maybe approach is surface to surface, maybe track is small, and I'll just click on apply and close. So this way I created a contact pair attribute. Let's create one more attribute, that is a constraint attribute. So I know that I want to fix this bottom face. Then I'll first select this bottom face and then create the constraint attribute. So you know the constraint attribute is generally specified on the face use. So I'll just select here pick face use icon and then I'll just select this bottom face. So this is pointing towards the solid side. So once done with this selection, again same procedure. I'll go in the create problem definition. I'll just select the constraint here and CAENexus will assist me with some abstract entities and the abstract relations which are relevant to my geometrical selection. So in this case, I'll go with R solid fixed 2D. So you can see now this is the relation, but it is not showing here at the bottom side. The reason is this relation is already present here in my class relation window. If it hadn't present here, it would have shown in this window. So I'll just select this because it is selecting my intended geometrical entities. I'll just click on this checkbox and I'll just click on next. So this is opening my attribute editor. I can give the details like subcase ID. So I want to constrain in both the subcases. I want to constrain all degrees of freedom. And I'll just click on apply. So this way the constraint attribute has been created. So this way one can make use of simulation author mode and can set up the case relevant to model. Now if you compare this tutorial with earlier tutorial, then in earlier tutorial we directly specified the attribute on the classes or the relation, whereas here first we selected the geometrical entities and CAENexus helped us in finalizing the classes or the relation. So these are the two ways by which one can set up the case. So you can use any method as per your convenience. Now once done with this, we can save this abstract model file. To save, one need to click on this save icon Then I'll just select the abstract model file with which we started, and I'll just click on this save icon. So this way one can save the abstract model file. Now whatever attributes we created, those will get reflected in the saved abstract model file. So the next time when you'll use that abstract model file with your CAD, these newly created attributes will be considered there. Quick summary about the simulation author mode. So if you're not sure about the classes or the relation on which you should specify the classes, then you can make use of the geometrical entities, and CAENexus will help you to finalize the classes or the relations which are relevant to your geometrical selection. Secondly, once you entered into the simulation author mode, you cannot go back to the normal mode. Third is you can save the abstract model file, and that saved abstract model file you can use in a usual way when you start a new session. But if you want to continue in the current session, then you have to first go in action, reapply, and you have to click on class attribute. Then only the newly created attribute will be considered in the current session. But if you save the abstract model file and start a new session, then there's no need to go in the action and reapply the class attribute. Another point is the classes relation or the attributes from your parent AMF which are not relevant to your CAD model, those will be still shown in the simulation author mode. So that's all about this simulation author mode. I thanks everyone, and if you have any queries or question, then please feel free to contact at support@mosenexus.com, and we'll get back to you accordingly. Now, in next tutorial, we will see some more details related to simulation model. Till then, have a good day. Bye.